Welcome to Get Your FRQ On. This is from the 2003 exam. It's question number 2, and it is calculator active. In the question stem, we are provided with a particle moving along the x-axis, a velocity function v of t, and the initial condition that the position of the particle at time t equals 0 is 1. In part A of this question, we are asked to find the acceleration of the particle at t equals 2 and determine if the speed of the particle is increasing at t equals 2 or not, and to explain why. Since the acceleration at time t equals 2 is the rate of change of velocity at time t equals 2, a of 2 is just v prime of 2. All right, we're given in the question stem that v of t is the opposite of t plus 1 times sine of t squared over 2. And since this is a calculator active question, we can use our calculator to determine the value of both v of 2 and a of 2. In order to find the value of a of 2, we use our calculator to determine the value of the derivative of our v of t function at t equals 2. That turns out to be 1.588. Now, because this is a calculator active question, you will have to connect whatever you're asking your calculator to do to the given information. We are given a function v of t. We are not given a function a of t. So we have to state in our work that our function a is equal to the derivative of our velocity function. Typically, when you're dealing with motion problems, that is going to be the case, but you do need to explicitly connect a new function that you are introducing to one of the given functions or tables or whatever. All right, so a of 2 is 1.588. To determine if the speed of the particle is increasing at t equals 2 or not, we have to check the sign of both a of 2 and v of 2. It doesn't really matter what their values are, we just need their signs. If a of 2 and v of 2 have the same sign, then the speed of the particle will be increasing at t equals 2. If they have opposite signs, in either case, then the speed of the particle will be decreasing. We already found a of 2. A of 2 is positive 1.588. Now we just need to find v of 2, which again, we can use our calculator for. Don't need to. If you don't use your calculator for this, you can get an exact expression for this. However, you will have to be able to determine the sign on this. Negative 3 times the sine of 2. Well, negative 3 is negative. Sine of 2, is that positive or negative? Right, it turns out it's negative. 2 radians is not quite all the way over to pi, so sine of 2 would be positive. So we have a negative times a positive. V of 2 is less than 0. Now, since a of 2 is positive and v of 2 is negative, the speed of the particle would be decreasing at time t equals 2. In part B, we are asked to find all times t between 0 and 3 when the particle changes direction and to provide justification. The particle will change direction whenever v of t equals 0 and also changes sign. That's an important distinction. V of t could be 0 and not change sign, but then the particle doesn't change direction. In order to change direction, it must also change sign. All right, so our function v of t will be 0 either when t plus 1 is equal to 0 or when sine of t squared over 2 is equal to 0, which means that the solutions would be t equals negative 1, 0, and the square root of 2 pi, which is about 2.507. Now, since we're given a specific interval here, t needs to be between 0 and 3, exclusive, t equals negative 1 is not going to be a solution. It's not inside that interval. T equals 0 is not going to be a solution. It's not inside that interval. T equals the square root of 2 pi, which is about 2.507, is in that interval. So the square root of 2 pi is the only value of t we actually need to check. All right, so only t equals the square root of 2 pi is in the interval. So let's split that interval from 0 to square root of 2 pi and then from square root of 2 pi to 3. In the interval from 0 to square root of 2 pi, the velocity function is going to be negative. And for the interval from the square root of 2 pi to 3, the velocity function is going to be positive. Therefore, we know that the particle does in fact change direction at t equals square root of 2 pi. In part 3 of this question, we are asked to find the total distance traveled for time t equals 0 to t equals 3 inclusive. Total distance traveled is a pretty standard integral to set up. We take the integral from 0 to 3 of the absolute value of v of t dt, right, which we can set up as two different integrals. That's the integral from square root of 2 pi to 3 of v of t dt minus the integral from 0 to square root 2 pi v of t dt. However, this is a calculator active question, so as long as we set up the integral that we need, we can use our calculator to calculate its value. The total distance traveled would be 4.334 units. In part D, we are asked what is the greatest distance the particle is from the origin on the interval from t equals 0 to t equals 3. From part C, we know that the total distance traveled from 0 to 3 is 4.334. Using our calculator, the distance traveled from 0 to square root of 2 pi of v of t dt is negative 3.265, and the actual position of the particle, x of square root of 2 pi, can be found using the integral 1 plus the integral from 0 to square root of 2 pi of v of t dt. Remember, we were given the initial condition in the question stem that the position of the particle was 1 at time t equals 0. So at time t equals square root of 2 pi, the particle is at negative 2.265. In addition, the position of the particle at t equals 3 can be found using the integral 1 plus the integral from 0 to 3 of v of t dt, which is only negative 1.197. Again, this is a calculator problem. Use your calculator to determine these values. So x of 3 is negative 1.197. X of 0, we were given in the question stem, is 1. And x of the square root of 2 pi is negative 2.265. We're only concerned about the greatest distance from the origin, so we don't really care which side of the origin it is on. So if we look at the absolute values of these positions, the greatest distance the particle is from the origin is 2.265 units. It happens to be on the left, but so what?